Okay, welcome back. We're now up to section 1.7. We're going to talk a little bit about function notation. We kind of want to use that to evaluate functions at given values. Okay, so let's turn that on. Okay, there we go. All right, so once again, this notation, when we see f with this parentheses, we read f of x. So basically it's saying, hey, let's find the function value for f at the value if we put x in. And a lot of times we'll put a number in there is what we'll see here. So let's kind of see what that looks like on just a few problems here to evaluate. All right, so we want to evaluate the function value when x is 0. So we say f of 0, f of 1/2, and f of -2. So very simply, all you have to do is we're saying, hey, what's the function value when x is 0? So put a 0 in for x. Well, we know function value there would be 8. And since it's a function, we know there's only one value that it could be. All right, how about f of 1/2? Well, I'll put a 1/2 in for x, that's 2. 2 plus 8 is 10. And then f of -2, if I put a -2 in here, that's -8 plus 8. Oh, that ends up being 0. Okay, so that actually gives us an ordered pair, guys. 0, 8 would be a point on the graph. 1/2, 10 would be another point, and -2, 0 would be a point. Remember, these are the inputs, the x values. These are the outputs, or the y values. So it works out pretty slick. All right, let's try that same thing, except now let's try this with a graph. Oh, okay, so now we're not actually going to put the value in, but we're going to go to the graph. What's the function value when x is 0? Well, if I go to 0, what's the y value? Well, it's 4. Yeah. What's the function value? What's f of 1/2? What's the function value when x is 1/2? Well, 1/2 looks like it's right at 0 there. And then what's f of -2? Well, let's go to -2 here. Oops, actually, I did that. I think I did that. That was a 3 there. Sorry, silly goose. Counted wrong. When let's go f of -2, that's going to be up here at 4. Sorry about that. Made a little mistake there. Counted wrong. So, all right, so just go interpreting from the graph. All right, so as we get some terminology here, let's talk a little bit about dependent and independent variables. X is going to be the independent variable because we can choose that to be anything we want to. And the output, or the y, is going to be the dependent because that depends on what you choose for the x value. It kind of depends on that. So whenever we do that and we graph, we always want to put the independent variable on the x-axis. And then, of course, the dependent is the y. That's what we want to do here. So in this case, our distance is going to be dependent on the time that we go. So again, you can kind of see what the graph looks like as we go there. And we've all graphed things before where, okay, if we graph the function, yeah, we should be able to graph ordered pairs, 0, 4. Remember, x always comes first, 1, 5, 2, 6. Should be able to do those. If they give you a set of points, don't connect them, just put the dots, and we'll have that as well. One thing that you can always do if you're given a function is you can choose whatever input values that you want. Choose your x's. Well, make them easy. Put them small, nice numbers, around 0, so you don't have to make a huge graph. But you can just choose your x values, then put them in for the function and see what you get out. Well, now you've got an ordered pair, and you can plot a few dots. And in this case, because it is a function in an equation there, we do want to connect those with a solid line. Okay. All right, so there we go. We also have things called mapping diagrams. These are kind of interesting diagrams. This is where this is the input, and this is the output. So 3 goes to 2, 5 goes to 6. 7 goes to 10, and 9 also goes to 10. Now, this is a function. Now, remember, it's okay for 2 inputs to go to the same output, but you can't have an input going to 2 different outputs. And again, you can see that this graph does pass our vertical line test, as we have it there. All right, last thing that we have here, being able to write maybe a function. Carnival charges $5 entry fee and $2 per ride. So we're going to go 5. If we just did this as a function, we could say cost is a function of x. We could say it's going to be 5 plus $2 per ride. Okay, well, if we're saying, all right, what's the value of the function for an input of 12? That means, what if we want to go on 12 rides? Well, I'll just take 5 plus 2 times 12, put that input in, 24, that'd be $29. That would be what the price or the cost of us to do that. Okay, so get used to that notation, be able to put things into a function, get the input, output. Should be fairly easy. Good luck with that. That's 1.7. Until next time, I'm Mr. Boone.